My name is Sebastian, and in this video I want to talk about effective Maven usage, how to use Maven effectively to build your projects, mostly enterprise projects, but in general, what are my recommendations and tips and tricks. So Apache Maven is widely used out there in the ecosystem. It's by far the most widely used build tool that I use in my projects. Pretty much all of my projects are built with Maven. And there are some things I want to talk about just to make it more effective and also more pragmatic. Things we need, things we maybe don't need. I have a project here that is, of course, a Maven project. I use Quarkus. This is my Quarkus playground. And there are few things that I want to start out with and to show, because especially I would like usually to have some sort of straightforward use, very simple and pragmatic use of Maven. So how did I get this POM? This is called a pom.xml project object model. It is fairly straightforward and simple, I would say. Well, originally I created one with this code with Quarkus tool that you can go to code.quarkus.io, and this can generate an application with some specific dependencies to start out with. However, I'm not super happy with what this generates because I usually go and then reformat it a little bit. For example, I insert some blank lines to make it a little bit more readable, and I would also typically remove some stuff. So for example, I would argue not all of these properties are required. The properties can be set in this properties block here and then used, but most of them I would just use inline. For me, that's more simpler and straightforward to read. Okay, then we have dependency management, some dependencies, some plugins. That's also an interesting thing to talk about. And then maybe some profiles here for the native build. Okay, so my project looks a little bit leaner. I only usually care about group ID, artifact ID. You might set a name. I usually don't care about all the extra information such as committers, Git repository, things like that, because I would argue that's not the place to really where you're interested in that in the Maven build. Typically, we have some dependency management block that's quite interesting, and then you can just build it here. That is being built via the Quarkus Maven plugin. This is actually a little bit special, because usually you would have something like a packaging, a jar, or a war in an enterprise context. Quarkus is being built a little bit differently. But in general, how do I build this? Well, this is also, I do this quite straightforward. I use the Maven invocations, or just the Maven build tool that we can have here. I use this particular version. It's not the very, very latest, but good enough. And I don't usually use a wrapper, I just use it straight away. You might argue, okay, there is some pros and cons of using a wrapper or not. I actually like to keep my repositories clean and away from that, but that's a different story. And then, well, what I do, I just invoke the build, usually using this package goal. So there are a few goals there that are a few different ones that already have some specific, goals and phases that then are being triggered. So for example, this package one would do all of the resources. There might be some copying, some filtering if you use this, compile the code, compile the test code, run the unit test. This is a surefire test. We will talk about this in a second. And then just package everything together. In this case, it uses the Quarkus Maven plugin to do so, which also then does the Quarkus augmentation. So that's already something I like to use. The conventions, we will talk about the structure in a second. And also for invoking the build, I usually use actually this command, Maven clean and package. So there's something a little bit to talk about that. Which command you would like to use, because, well, there are some opinions on this. Usually a lot of people use Maven clean install. What is the difference? Well, the install phase does the package as well, and then at the end takes the artifact that has been built, for example, your jar file here, and then installs that into your local Maven repository. So then it will actually be available under this, and another project could potentially use this particular dependency or this project as a dependency. For an enterprise setting, this is usually not what we want, and I will talk about Maven modules and why not to use them at the end. but this is already sufficient that we say, okay, we use the package phase. Why do I use clean? Well, because I tend to play around quite a bit in my demo projects and also in client projects with saying we want a new version. I upgrade, for example, here the Quarkus version, I change the Java version. This happens quite often. And invoking the clean really doesn't take a lot of time. So here that's 100 milliseconds. So potentially your build gets slightly slower by adding clean. But for me, the few cases where you need clean because then some Java class version change, and then this is a little bit hard to debug. You start the application and something doesn't quite work, and it takes actually much longer to find it out why this is the case than to just always clean. So this is what I use, Maven clean package. You also already saw that I use an alias in my shell, so I don't type Maven clean package. I just type an alias that then is expanded. This is definitely recommended because, well, you type these things all over again. That's then what I use. If you heard about using Maven verify, well, this is very, very similar to package actually. Verify, I first of all don't like the name because verify, it sounds just like test or so, that it doesn't really build or package something, which is not true. It does package. What is the difference? There is a notation of integration test, but we will come to this later. This is a little bit misleading. This doesn't run the fail-safe integration tests. What these are, I'll show in a second. So actually, it doesn't really matter which one. That's my opinion for most of the projects, unless you change something in the setup. So I always, for that reason, use package, or actually clean package. So Maven clean package. That's literally what I always execute. If you have some tests, and you should have some tests, let's talk about them as well. So I said we should use the conventions. So this particular project here, let's open this up as such, has a specific structure. We care about this one, source main test, and then let's do this source main Java resources and source test Java, and maybe also test resources. This is the default structure that we have in a Maven application. So source main is just your main production code, typically the name of your programming language. For most that will be Java, and then resources for some extra resources. There are some other potential folders available. You can already have some filtering that's enabled out of the box, and you might have some other assembly scripts. I won't go too much into detail in this video because for most of the projects this is actually not required. This is usually a special case. So what I want to focus on in this video is building enterprise applications most of all, and then also building your typical Java application, something like a standalone tool that you can run with java-jar, or building command line tools, for example, that you can have native builds for. We'll see this a little bit later with Quarkus as well. So these typical examples. Once you go into mobile apps, then this might change a little bit. When you say this gets more complicated, then actually Gradle might be another interesting choice. Okay, so for this, that is a default structure. Test Java contains our test code. And now how to invoke this. We can have a look at the documentation here on the website. There is a plugin, and there are mainly two plugins that we're interested in and that come out of the box that are already included. That is, one is the Surefire plugin, the other one is the Failsafe plugin. What do they do? The Surefire plugin, that's the interesting one. We've already seen in the output that this actually runs. If I invoke Maven clean package, we will see that I have the Surefire plugin that runs the test. This happens out of the box with the package phase. So this runs the Surefire tests, and typically if I include JUnit, and I do, then this runs the Surefire plugin, runs your test platform. For me that's JUnit, and executes all the tests. All the tests means, well, which ones are included? It includes per default a structure, you can see this here, that is test classes that start with test or end with test, TEST, or test case, and these are included. So all of your, sometimes you can refer to them as unit tests or code level tests, basically tests, TEST, they are executed, something like this. So we say, okay, coffee shop test, it is called TEST, that's why it's included. This is an interesting convention that we definitely should follow, because then we don't have to configure anything. We just call our test class like that, and then this is being executed. We see this in the test phase here. We have our test run with this one test, and that's included. We don't need to do anything else. Okay, great. What to do with other tests? So there's another notation that we don't include in the Surefire tests, that are integration tests. And they are also included out of the box if we call our tests IT for integration tests. So these tests have to end with IT, integration test, and they are not included out of the box in our package phase. So we see that this integration test already assumes that our system is running, and it contains an HTTP client, connects to a local host, 8080, and so on and so forth. This would not work because there is no application running. This depends how you build up your tests. But anyway, what I'm doing here, I typically out of the box have two sort of test scopes, if you want. Something that I call code level tests. It doesn't have to be a unit test per se, but basically your unit tests, TEST, and integration tests. And with the integration tests out of the box, you can run them separately. You don't have to. I could rename this test, or I can say, well, please run my failsafe integration test as well. How would I do this? I have a shortcut for that as well. There's a plugin failsafe integration test, and then failsafe verify in order to make the build fail if something fails here, which we see, okay, this actually does fail a while because it tries to connect to localhost 8080. This is typically what I do. So here, this is a smoke integration test that just connects to the running application, sees whether everything is all right, whether it came up. And of course, this doesn't work now, but I then include this either in a local build pipeline or in a CI/CD pipeline to run them separately. So typically I have something like Maven clean package everything together, then start my application, and so on and so forth, and then run the integration test on that. We can do this real quick. I built my application again with Maven clean package. I say, okay, please start up my Quarkus app, and then, well, I need a database here as well for my particular example. So let's do this. I start my application, and now in a separate window, I can now run my integration test that now should be green. So this is just one particular example how you can structure that. So you get this out of the box with using the conventions, having the integration test by calling your class IT. Okay, so that's that. Now let's talk a little bit more about executing this. What else can we do? Usually this, you should keep it at that. Of course, you can ignore specific tests with just disabling them, or you can say, I would like to not run the test. So there's one thing I would just want to tell you because it might be helpful. That is called -d skip tests. So here, it just skips the tests, but there's also Maven test skip. Where's the difference? This one, the second one, doesn't even compile the tests. So of course, take this with a grain of salt. You should always have tests that compile and everything. But while you're in a refactoring, process, and then just say, okay, can I just quickly, for some reason, compile my production code? You can use this one. But then please, fix the compilation errors and fix your tests. But this is something here as well. -d test, which you can see in the Surefire documentation as well, runs a single test. So you can say, don't run all of them, run a specific test, and you can check out the documentation here, which particular test you would like to run, and so on and so forth. So there's more to that. But these are basically the properties that I would like to use, or that I would like to stick to, unless you have a different reason. So I would always use the conventions. Okay, now, with regards to our build, let's talk about a different thing, that is the dependencies, which is also a very important topic. That now we see, okay, how do our dependencies for application get in here? And this is important to pay attention to, because it's not only about the dependencies, but all of the transitive dependencies. Okay, but first of all, let's talk about dependency management. Typically, this block dependency management can define some dependencies that then we might add in our dependencies block. So dependency management only defines the dependencies with the versions and maybe some other properties here, but it doesn't use them yet. So they don't end up in our actual build artifact, unless we also specify it here in the dependencies block. Why would you do this in these two steps? Well, because then here I don't have to specify the version. For example, I just say, okay, which dependency is being used here. The dependencies in the dependency management can be used here directly, or what I do as a BOM, bill of materials, that then in our case uses the Quarkus one for a particular Quarkus version that I can specify here in my properties block. That's the version I have right now in this project. And then we can have a look at that and actually see the Quarkus BOM as an example. My IDE resolves this, and then I see, okay, I have a lot of Quarkus stuff here in the dependency management block and all of these things that I might add. They are not added yet, but I might add them. Okay, how can I see what is actually being added? Well, there are a few ways to do this. One tool that is very helpful is a so-called dependency tree. I can invoke this with Maven dependency tree. What it does, it displays a tree of the actual dependencies that will end up in your artifact. So if I have a look at my jar file later, or jar files for Quarkus, I will see what is being added and basically where they come from. So this is kind of interesting. With the scope of the dependencies, compile just means, okay, it will end up in my build artifact. You will see, okay, this ASCII art drawn tree, where they come from. So if I say, okay, I have this particular, I usually use it in such a way that I say, let's pipe this into the editor with Vim. I have, for example, some issue with logging. Okay, where are these dependency actually being added? So, okay, this is just a test dependency, but you get the point. You might see, okay, where does this come from, and so on and so forth. Okay, from this particular dependency. With Quarkus, this is a little bit different because that's usually not an issue here, but for regular enterprise projects, this can be quite helpful. So this first thing, dependency tree, might help here. Another interesting artifact is the so-called effective pom. This is kind of interesting to have a look at. Why? This is an XML structure, the literal pom, as if we would have written this from scratch with all of these conventions already being resolved. That means there are a lot of plugins, as you can see here, that just come out of the box. If I don't define them, then the default plugins and default versions with the default configuration is being, well, added. If I want to have a look at that, this is called effective pom. So we can do this on the command line with this command help effective pom, or your IDE might also support this. Your IDE typically is quite smart with that. It can generate a diagram of the artifacts as well, or it can just show the effective pom, which here is quite big because it includes all of the dependency management block. They are not used, but you know, they are just resolved here. That could be added. If I close this, then I see the actual dependencies and, well, not where they come from, but the actual dependencies here. And then here also the actual plugins. So the plugin management with all of the default Maven plugins, for example. So that are being used here. We see failsafe, clean plugin. We use this resources. This is all just default stuff, but it might be quite helpful, especially with regards to the versions. And then we might see, okay, no, we need to redefine some version here for some reason. And the effective pom can be quite helpful here. Okay, so that's kind of interesting. With regards to dependencies, one thing I definitely would like to point out is that keep the dependencies in general as few and as small as possible. So if you don't need a dependency, then don't use it. With the Quarkus features here, that's a little bit different. If I use a feature, of course, I need to add the dependency, but I'm talking more about some third-party dependencies, something like Apache Commons, that's quite common, something like logging frameworks, that's a big topic on its own. And in general, the fewer dependencies you have, the better. It's not just about the dependencies, but also the transitive dependencies. We can, for example, here in our IDE, have a look at one particular one, and it will include its own dependencies here, and so on and so forth. So this might be quite a thing. So be aware of that, and in general, the fewer dependencies, the better. Okay, now what's What else is to say about Maven? What I like to use Maven for is to build Java. And only that. Build the Java artifact and have everything, to do what is required to build that artifact and nothing more. So in other words, I don't advocate for overusing Maven, because especially here in the plugins section, you can use all sorts of stuff. People use, for example, Docker plugin or the Jib plugin to build containers. And in this case, I would say, at least that's my recommendation or opinion, I would like to use the tools what they're good for. So it's to say, okay, Maven is really, really good for building these Java artifact structures, and the different tools such as Docker or Podman or what have you is better suited for building containers. So I don't run a bunch of plugins here, because in the long run with the more complex projects, out of my experience, you don't do yourself a favor. What I do instead is to say I build my project with Maven, for example, here, and then if I need something else, I say, okay, then invoke a Docker build, for example, and then do this on top. And then if there are too many commands, just write a shell script or some local pipeline automation that you can use. You can have a CI/CD, and you should anyway, that then invokes these steps one after another. And I would prefer this over some overusage of Maven here. There is only one exception, that is when you need a plugin that actually changes the way how your Java application is being built. And of course, the obvious example here for Quarkus is the Quarkus Maven plugin, because it does different things. That's not the same like saying I build a regular jar file and then I do something with the jar file and process it. That would be different, but it is a different jar file that is being built. And this one exception is if you would like to have a native build here. For example, then I say Maven package, and for example, Quarkus packaging type native, that then does this differently. I think it is Quarkus package type. It does it differently, and now it is being the native image is being built. So you don't even need to add a profile per se in your build. I would also actually stay away from using too many profiles, because that suggests that you would need to build your application sort of differently for different environments or different scenarios. And for a bunch of reasons, I would also stay away from that. Is to say, okay, you would always want to build the same thing, and if you need a different configuration, bring it out later from the outside. But that's also a different story. Okay, as for properties, as we've seen here, we're almost through this. In general, I would also like to keep this rather simple. There are some plugins and some configuration options that you can actually set via property. So you can check this out in the Maven documentation, which then I would prefer. So I could also instead define the Maven compile plugin and say block something like this here, block configuration, set the Java version, or you say, okay, this is doable via property, which of course is much shorter. Then I set this, set that, set the source encoding, otherwise there's a warning, and then you're done. Maybe you have 1, 2 more properties, but this is also using the convention because these properties are being defined by Maven. So that's another interesting thing. In general, keep all of the pom.xml stuff as simple as possible. That's definitely a recommendation that I have. So that's about properties. We're almost through with all of the points I have to say about this. One more thing is about Maven modules. So what is a Maven module? A Maven module is if you would have a block here that is called modules, and then you have a structure that is typically done with subdirectories, where the subdirectory is not source or something like that, but a different project. Now, this is a little bit, well, it depends what you're trying to do. In general, I would like to stay away from Maven modules, at least if the Maven modules are being used to split up something that at the end should be one deployment artifact or one Maven artifact again. What do I mean by that? Sometimes you have a structure, something like your application core, web, data. That's typical in enterprise projects. I also created a video about that where I can share my experience with this, that I would just avoid if at the end all of this core web data stuff just gets boiled down back to one deployment artifact, like one jar file or one war file, where then you might say this doesn't make sense to first of all define different modules if something always gets shipped as one artifact. Now you might say, no, this is not true. It's more clean or whatever for the architecture. And I say, no, you get very little benefit with a lot of extra headache with a more complex build. The build takes longer. It's much more complicated to maintain because you have multiple build structures that all need to be in sync. So you're not doing yourself a favor. If you would like to be more stricter with your architecture and which module and which type of which part of the code can access what, then you should use extra code quality checkers such as Arch Unit that check this, that everything there is correct, but not make the build more complex. There's only one exception when you say you build an actual dependency or something that will be used as a dependencies in multiple projects. So where you say you have something like your own utility that then is being used, then you typically have something like Maven install or even Maven deploy, and then you can use that. But other than that, I would not use any Maven modules. Here, for example, I have a different Maven project that is a system test project that on purpose I don't tangle together with my playground. So this just out of circumstance resides in a subdirectory, but that doesn't matter. It has no connection. So here you cannot access the code, which is on purpose. I don't want that in my system test project. It should be sort of black box in this setup. So that's different. But I would usually try to avoid the Maven modules. So more often than not, this is making it more complicated, at least in my experience in projects. So that's pretty much it. These were pretty much my tips for an effective Maven usage. To sum it up, keep it simple as possible. Try to use the conventions that are there. You might check out the documentation. This already can be helpful. You also might check out the example project that I have here just for some idea what you can do with Quarkus specifically. Then use a just very simple invocation, maybe in your command line. If you use the command line, use aliases for that. That's really helpful. If you need to debug your build, dependency tree, effective POM, and the IDE, structures of your of these hierarchies can be very helpful. Other than that, just keep it simple. If you need a different tooling on top, I would very much encourage you to have a different pipeline with other tools that are invoked afterwards, not everything together in the Maven structure. So now I'm curious what you think about that. Do you have some other recommendations or other experiences in your projects? And especially, what do you use Maven for? Maybe you use Maven to build something else, not on enterprise projects, but a different setup that might be a little bit more complex to handle with Maven. Please let me know. And if you liked the video, I would really appreciate a like. As always, thanks a lot for watching. Bye.